Thank you, Fabiana, for the introduction, and welcome everybody to this presentation about product service system and sustainability. So throughout this presentation, we are going, after explaining you the context in which we are operating, we are going to explain to you the concept of product service system and the link with sustainability. And after that, we're going to present briefly two models that allow us to assess the sustainability of product service systems. Next slide. Okay, so let me present us. So I'm Mattia Galimberti, and she's Veronica Arioli, and we are both postdoc from University of Bergamo. Specifically, we work in CELS research group, which deal with industrial systems, engineering, and logistics and service operations. Okay, so modern industry went through different revolutions, as you may know. So we had mechanization, electrification, automation, digitalization, and now we are in the fifth revolution, which is well explained by these three main pillars. The first one is human centricity, which means to bring human back to the center, focusing more on operators' well-being and social opportunities. Then we have resilience. Resilience means to adapt rapidly and effectively to changes in the context. But in this presentation, we want to focus on sustainability. So sustainability is described by the TripleBottom Line definition with these three main pillars, which are economic, environmental, and social. So we have these three dimensions. So being sustainable means focus on the profit, but also paying attention to the environment and the social dimension. Recently, some organizations in the world set some rules in order to stimulate the attention to the environment. For example, we had the Paris Agreement back in 2016, which has the focus of limit the global warming below 2 degrees compared to pre-industrial levels. And more recently, we had the European Green Deal, which has the objective to achieve climate neutrality by 2050. In order to achieve this, to meet this regulation, companies can adopt different strategies. For example, they can adopt circular economy, energy efficiency and renewable energy, process optimization and digitalization. All of these dimension is easy to understand how they can help to reduce the environmental impact and to enhance recycle and reduction of the use of materials. But today we want to focus on business model innovation, because recently literature stated that a change in business model can help in enhance sustainability, specifically through product service systems. What is product service system? Product service system is a business model which combine the offering of a product together with some services. So the focus is no more on the product itself, but on the product together with the service offering. Let me give you some examples. First of all, we should say that product service systems is defined by these three main archetypes, which are product-oriented, user-oriented, or result-oriented, defined by Tucker in 2004, and then used a lot in literature. For example, if we talk about product-oriented, it means to have a product at the center of the offering, but with some additional services. For example, IKEA sell furniture, but with some, for example, the home delivery service. iCloud is a service from Apple, and the idea is to buy the device and then you can pay a fee in order to access the data storage. Then we have user-oriented, where you pay for the use of the product, but no more for the ownership of the product. So for example, if I rent an e-scooter, I do not possess the e-scooter, but I can use it, of course. And then we have the result-oriented offering. And what does it mean? You're no more buying the product, you're no more buying the use of a product, but you're just buying the result. So the experience connected to one product, technology, and so on. So for example, Netflix or Spotify. For example, with Netflix, I'm not buying a DVD, I'm not buying the use of a DVD, I'm just buying the experience of watching a movie. And then we can have different service offering. We can see them in the next slide. Okay, so we can have different services that combined can create a service offering. I leave the floor to Veronica now.
Welcome everybody, also from my side. And as already stressed by Mattia at the beginning of the presentation, and somehow highlighted also by the definition of the PSS, the interest of manufacturing companies in this business model relies not only on the possibility of strengthening the company market position and creating competitive advantages, of course, rather than traditional product sales offering, but also, and in particular, from the benefits that PSS can generate at the environmental, economic, and social perspective, and as highlighted a lot by the literature. The sustainability benefits that PSS can generate and can be classified following the TripleBottom Line framework, as highlighted and already introduced by Mattia at the beginning of the presentation. And they are here reported on the right of this slide. We will go through all of them in the next slides. And what I want to highlight here is that we also reported the main PSS drivers and characteristics that affect and influence the sustainability benefits of a product service system. So starting from the environmental sustainability perspective, we can say that product service system can generate resource efficiency in the sense that it can reduce the quantity of materials that are consumed in the total life cycle of the product, and also reduce the waste generation during the life cycle. This mainly resulting from first of all, the dematerialization of the offering, because we are like in a result-oriented PSS, we are providing the results instead of the product itself, and also by the transparency that is enabled through the digital technologies that can monitor the product life cycle, and therefore they can lead to a more accurate consumption of resources. But also this resource efficiency and waste reduction can result from the lifetime extension of the product, which is basically enabled by the services that can be provided along the life cycle of the product, the preventive maintenance services, for example, or the upgrading and the retrofit of components, which then also can postpone the fast replacement of products and therefore reduce the this resource consumption. Resource efficiency also is resulting from the intensification of the exploitation of the product and the existing asset, like said before, like in use-oriented PSS, where more than one user can, like in sharing offers, more than one consumer can actually use the same product, and therefore as last PSS driver, we can also find the improved recycling and reuse of the product, allowed by, for example, take-back services at the end of life of the product, and of course, facilitated by user-oriented and result-oriented scenarios where the ownership of the product is retained by the company. These all can reduce the pollution emissions during the whole life cycle of the product. And we can also say that, for example, this can result specifically from the extended lifespan of the products and the change of consumption patterns, because if we think about user-oriented scenarios like sharing and pooling, the same user are sharing the same amount of emitted carbon footprint. By moving to the economic perspective, PSS are able to increase and stabilize the company revenue generation, of course, by providing services instead of only product sales, if we think about manufacturing companies, but also it can increase and stabilize the revenue generation of service providers, because they can partner together with the manufacturing in the PSS ecosystem. PSS also can allow to preserve costs during the entire life cycle of the product, and the main reason behind this is related to paying attention to the life cycle of the product, thanks to the maintenance services or upgrades that can extend this lifetime, but also from mainly the retaining of the ownership in use-oriented and result-oriented configuration, because specifically these categories enables the customers to move from a CapEx logic into an OpEx logic, where lower but recurrent expenditures are done during the entire life cycle of the product. And this can decrease the total cost of ownership for the customer, which then can have access to more possibilities. And last but not least, we have also the social perspective, and PSS in the literature is said that it can contribute to create long-lasting relationship with the customer. Once again, thanks to the lifetime extension, the change of ownership, and specifically in a result-oriented configuration, the involvement of the customer in the value creation of the offering. It can also generate new job position, and this is basically enhanced by the extension of the company business portfolio and the business opportunity of the companies, and the increase of the health and safety of the workers and the customers, thanks to the materialization of the offer, the transparency that we have said before, which can then also increase the satisfaction of these actors involved. Even though there are all these benefits that a PSS can generate, companies actually can experience some unexpected results. One of these is the service paradox, is known as service paradox. It has been defined in 2005, and basically the service paradox argue that substantial investment in extending the service business, so moving from a product-centric oriented to a service-centric oriented business, can lead, of course, to increased service offerings and higher cost, but does not generate the high expected returns. And this has been experienced by other authors investigating the service paradox later and also recently. These authors also starting to understand that in early stages of servitization, so in this move from the product-centric configuration to a service-oriented offerings, a manufacturing company can actually increase the margins, the profit margin effectively, but then in moderate stage or in advanced stage, this increase is not so high. And so this is not really profitable for companies. And even in the last study that we performed in 2023, where a survey were targeting more than 300 servitized manufacturing firms, we found out that services and the revenues from services, and specifically multi-year services or more advanced services, only corresponds to no more than the 25% of the total share of revenues in the majority of the respondents. So confirming the 2005 results of other authors. Another unexpected results, but now involving the environmental dimension, is defined as rebound effects. The rebound effects are systemic responses to initially sustainability-oriented actions that, however, at the end generate negative effects on the environment. And the literature said that rebound effects can offset over the 55% of the expected outcomes of well-intended action, hindering, of course, the full potential of sustainability of this action. And these terms, the rebound effects, come generally from the energy economics and the circular economy domain. But however, since the product service system are very connected with the circular economy dimension, because product-oriented, product service system can enable some strategies of the circular economy, we started to, and other authors started to empirically look and experience this rebound effect also in the PSS domain, as in this study involving 103 cases. The authors found out that in each of the cases involved in different PSS types also, they experience rebound effect, or even known as a backfire effect. Examples of rebound effects are, for example, the rental that can lead to additional consumption of products due to the released budget by lowering, of course, the purchasing cost. These and another example can be the less careful behavior of the consumers in case of the loss of ownership of the product, which can then at the end offset the potential positive environmental benefit. So the potential of this service paradox, the rebound effect in PSS solution highlights, of course, the need of quantitatively assessing the sustainability of PSS. And by looking at the literature on Scopus, we made a literature review, and we found out 48 studies that show the different methods and methodologies and their application for the scope of course of sustainability assessment of PSS. And by comparing these different methodologies, we found out that all of them adopt a life cycle perspective, and this emphasizes the importance of considering the entire phases of a product life cycle in order to demonstrate the sustainability impact of the PSS. But only few include simultaneously the different dimensions of the triple-bottom line, and even fewer can incorporate in the assessment the uncertainty of the results, the stochastic elements of the PSS, and the feedback mechanism that can arise from, for example, rebound effect or service paradox. And at this point, Mattia and I will try to show you the two approaches that we developed in order to try to address this need. And I leave the floor to.
Yes, because as Veronica was saying, we can say that PSS has the potential to increase, to enhance sustainability, but this is not taken for granted. So we need some models, some ways to assess this. So this is a framework that I developed during my PhD, and this framework has the scope to assess if what I called PSS opportunity has the potential to enhance sustainability or not. What is a PSS opportunity for me? It's a technology, a product, or an asset that a company commercializes. So a provider company commercializes. So the starting point for me is a provider company who want to explore the consequences from a sustainability point of view of adopting PSS. So the starting point for me, let's say, first of all, the framework has two levels, a preparatory level and a comparison level. So in the first level, we want to select the right technology, product, or asset, or what it is. And then in the second level, we want to assess which are the best conditions in order to implement PSS on this particular technology asset and so on. So the first point for me is to define a list of PSS opportunities, as I was saying, then to identify some criteria or parameters to rely on for the assessment, and then to evaluate just qualitative which is the best, which technology or asset has the potential to be the most feasible in terms of PSS that can bring more benefits in terms of sustainability after applying PSS, of course. So after selecting the best technology, so the best PSS opportunity, we go at point 4, where we define a list of scenarios. And then we start from the list of criteria or parameters of point 2 and we transform them into KPIs. And then we assess each of the PSS scenarios we defined based on this KPI in order to assess, again, which are the best conditions for this specific technology. So let me give you some example. For example, in a quick example in the machinery sector. So in the machinery sector, we define the best machine. So we are at the end of point 3, and then we go on from the next slide with the definition of PSS scenario. Okay, so these are the 3 scenarios based on the PSS archetype I showed you before. So the aspects highlighted in blue will be managed by the service provider in our scenario, and the aspects highlighted in orange will be managed by the customer. So in this way, we can build the service offering. And from this, they will arise some costs associated with the service offering. So based on the cost of these services, we will add a markup defined in percentage. And in this way, we can define an initial fee and a periodic fee that the client will have to pay in order to access the service. In this way, we have defined the revenue model. Then, as I showed you before, we need to define the KPIs. In this case, just to be quick, because due to also time constraints, we will select these 2 KPIs, so the net present value and the total CO2 equivalent emissions. So we want to assess which is the best condition to have these 2 KPIs as better as possible. And we want to assess from the provider and the customer perspective, again, the best condition. So next slide. Based on the markup percentages I defined before, we can create a matrix like this, in which there are all the combinations of percentages. So when the percentages are low, it means that the customer is paying not much for the service. Indeed, it is a profitable condition for the customer, but not profitable for the provider. Conversely, when the percentages are high, it is convenient, of course, for the provider, but not for the customer. In between, there is what I defined negotiation area, so an area where the net present value is close to the net present value that we had in the business as usual case, so where we just sell the machinery, okay? So this negotiation area is the area where provider and customer can negotiate in order to find a solution, to find an agreement, and to build together the product service system. Next slide. So these 2 matrices was built for one scenario, but then we need to build these matrices for all the 3 scenarios we defined, also putting number in it. I didn't put numbers for confidentiality reasons, because I had data from a company, but it's easy to calculate the net present value for each of the combination. Calculate for each of the scenarios. In this way, it is easy to understand which is the best scenarios from the economic perspective. After that, we need to calculate the CO2 equivalent emission connected to each of the service offering. And after that, we can address for both the assessment, so for the environmental and economic assessment, uncertainty and stochasticity through more for the economic one, Monte Carlo simulation. So in the end, we will find which are the best conditions for apply PSS in order to achieve sustainability benefits, both from the customer and the provider point of view.
What I did during my PhD research project was something similar, but as the one showed by Mattia, because still we are talking about assessment of the sustainability benefits or not benefit of PSS solutions, but the starting point was slightly different in the sense that the company that was involved, in my case, wanted to quantitatively assess the sustainability consequence of their existing service offering, because here we are in the case of a manufacturer that has already found a way of getting revenues from services. But actually, the focus here was to focus not only on the economic point of view, but specifically also on the environmental sustainability assessment of their existing PSS, and trying, of course, then through a what-if scenarios analysis to explore new PSS models. Somehow they already quantified them, but not really at a quantitative level, but only at a qualitative level. Now they wanted to have values that show the real impact of the services. And I did it through developing a dynamic total cost of ownership model and a total CO2 equivalent emission model that is enabled through the use of simulation. The scope, so the ending point in my case was, of course, identify under which conditions the PSS can bring benefits at a sustainability level, principally supporting mainly the customer in defining the best PSS offering for being more sustainable. So enabling the support to customer choices. And of course, the advantages of simulation relies on the fact that you can have a more dynamic assessment. You can include, as already said by Mattia, include the stochasticity of PSS elements like maintenance stochasticity, failure rates, lifetime extension that can be stochastic, and uncertainty. And of course, then the ability of exploring different what-if scenarios with a very low effort in terms of cost and time, and then supporting long-term decisions. On the other perspective, simulation can also oversimplify the real-world scenarios and lead to inaccurate prediction, but this really doesn't. This is a problem that everyone can deal with when using simulation, and also high because actually we are high dependencies on data and the assumption that we make in building the model. However, a good verification of the model with sensitivity analysis or in the validation of the model, like for example involving a case study, can really help in overcoming these advantages. speaking about simulation, there exists different paradigm of simulation, and they all suit for different scopes, and they suit for different abstraction level and level of detail that we want to reach. And in the case of my model, I decided to use among the three, so the system dynamics, discrete event simulation, and agent-based modeling. I decided to use the agent-based model. This because it is more flexible in terms of representation of the complex system, and in the case of the development phase, it can accommodate a high level of detail, complexity, as you can see also from the slide, while also guaranteeing an effective representation of the whole complex system. And also by looking at the literature, it was already used, and it suits for addressing the need of quantitatively assess the economic and the environmental sustainability of the PSS. This is the model hierarchy of my agent-based model. And as you can see here, I wanted just to highlight the different actors that are involved inside the PSS configuration, like the products, the install base, the services, the service technicians involved during the interventions and the services delivery, the employee, and the customer that, of course, with his choice can determine the different preferences in the consumption behavior and the service scenario. And I want to stress with this slide the product agent, which is fundamental for building the model. And I wanted to stress here the fact that it is represented from the manufacturing stage to the end of life, so the disposal. So looking at the entire life cycle of the product, and all the phases that can occur in the product life cycles are represented, like, for example, the failures of the product. And all these phases become the cost breakdown structure for the total cost of ownership model and for the CO2 equivalent emission model. And so starting from defining, as also mentioned by Mattia at the beginning of his framework, and in this case we are more on the lower level of his framework. Defining the list of PSR scenarios means also collecting all the characteristics of these offers, and which means product data, but also cost data. And after having defined a common unit, common functional unit in order to compare apple with apple, the different offer can be simulated in the simulation environment and compared during in real time during the lifetime of the product. Of course, the ending point can be is the analysis of the values that we have at the end of the simulation, and comparing and taking the mean values of the simulation, which can be put it into a trade-off matrix, like in this case, which on the x-axis we have the total cost of ownership, and on the other axis the CO2 equivalent emission. And this can give us the opportunity of understanding, looking at the trade-off between the two dimensions, which are for example, the cost-effective and environmental friendly decision for the customer, but also other we can enable other decisions like what I said here, budget conscious but not environmentally friendly decision, or even some environmentally friendly but not cost-effective decision. Of course, these can help in supporting the main point here is to support the decision of the customer. But as Mattia said, this can be also shift, and we can also look at the provider perspective, and this can be more complete in terms of actors and perspective involved.
Okay, so to conclude with our presentation, these are some key takeaways. PSS has the potential to enhance sustainability, but is not taken for granted. As Veronica was saying, we can fall into some contradictory outcomes, such as service paradox or rebound effect. Then we need to take into account all the life cycle of an asset when we want to assess PSS performances, and not only a short period of time, because otherwise the results can mislead us. And then we need to pay attention to the 3 dimensions of the triple bottom line to talk about sustainability. So economic, environmental, but also social dimension when it is possible. Then, as Veronica just showed to you, simulation can help us in addressing uncertainty, stochasticity, and yeah, in order to assess if PSS can really lead to enhance sustainability. So this is it for our side. If you have some question, we are here, even if we are a bit running out of time, but we can answer to all your questions.
Okay, thank you very much, Veronica and Mattia. Are there any questions for them? Any curiosity? Okay. No questions? Okay, so I thank you. And thank you everybody for attending this webinar on the CoDEMO 5.0 series. Thank you. Bye-bye.